Reshma wishes to mix two types of foods P and Q. So, we will consider, let x kg of food P and y kgs of food Q be mixed. First you have to write what x and y stand for. It has to be mixed in such a way that the vitamin contents of the mixture contain at least 8 units of vitamin A and 11 units of vitamin B. We now have P and Q, vitamin A, vitamin B, and the cost also we will consider. Now, they have to be mixed in such a way that the mixture of these two contains at least 8 units of vitamin A is what is given and 11 units of vitamin B, at least 11 units of vitamin B. Now, food P is costing rupees 60, cost per kg I will write, cost of food P is 60 rupees per kg and Q it is 80 rupees per kg, right. Now, this food P contains 3 units per kg, it contains 3 units per kg of vitamin A and 5 units per kg of vitamin B, and the other food Q contains 4 units per kg of vitamin A and 2 units per kg of vitamin B. The question is, determine the minimum cost of the mixture, determine the minimum cost of the mixture. So, what is the objective function which has to be minimized? Z will be minimize the cost, cost per kg of P is 60, Q is 80. We have considered x kg of P and y kg of Q is mixed. So, we have to minimize the 60x plus 80y subject to, write the linear inequalities one by one. The mixture has to contain at least 8 units of A, vitamin A. So, first inequality will become this 3x plus 4y at least 8 units. So, that will be greater than or equal to 8, and here it is 5x plus 2y greater than or equal to 11, and of course, x and y both will be positive, right. So, this is the actual linear programming problem. We have to draw these two inequalities. After that, find out what is the region, vertices, then go find out what is the minimum value for Z. Now, if I just go to the figure here, x, what are the coordinates I need? It will become x by 8 by 3 plus y by 2 equal to 1. That will be the first one. Second one is going to be x by 11 by 5 plus y by, it is 11 by 2. This will be equal to 1. So, x, the 2 points I need are, one is 8 by 3, the other one is 11 by 5. 11 by 5 is some 2 point some value, 2.2 actually. So, we will consider 11 by 5 here. This is approximately 2.7. 8 by 3 I will consider here, right. Now, y I need, the values I need are, one is 2 here, the other one is 5.5 or 11 by 2. 2 and 5.5 or 11 by 2. Right. First line, I have to join this 8 by 3 and 2. The equation was 3x plus 4y equal to 8, right? Okay. Next one, 11 by 5 and 11 by 2. When you do it on the graph sheet, take a proper scale and do it. So this is the line for 5x plus 2y equal to 11. Okay, right. Now when you go to the region, for both the lines, origin lie on one side of both the lines. So if I substitute here, 0 greater than 8 is false. So for first line, it is not on the side of the origin, on the other side. Second line also, if I substitute the origin, 0 greater than 11 is false. So for both the lines, region is going to be on the other side of the origin, or it's going to be here. So you will write here the feasible region is the unbounded shaded region. Okay. What are the vertices? I'll call this point as A, this point as B, this point as C. So first column will be the vertices, second will be the value of Z, which was 60x plus 80y. A vertex will become 0, 11 by 2. B is actually the meeting point of both the lines here. Now don't get it from the graph, simultaneously solve it and find out what is the point where they meet. Second line, I'll multiply it by 2. So I get a 10x plus 4y is equal to 22 when I multiply it by 2. Other line is a 3x plus 4y equal to 8. So when I subtract, I get 7x is equal to 14, correct? Just subtract it, or x we get it as 2. If I go back, substitute either in the first one or the second one, suppose I substitute here x as 2. So what do I get here? A 10 here plus 2y, this will be equal to 11. So on solving here, we get y to be 1 by 2, or the coordinate here is 2, 1 by 2. What is the third point is C, which is 8 by 3, 0, right? Now value for Z, if I substitute here, it's going to be 80 into 11 by 2, or this will be equal to 440, right? The second one will be a 120 plus 80 by 2, that will be a 40, or this value will be equal to 160, right? Third one will be a 8 by 3 into 60, 8 by 3 into 60, or this value will also be equal to 160, right? Now for both we get it to be equal to 160, right? Now first, all practical problems wherever it is an unbounded region, we have to check whether this 160 is going to be the minimum value, the minimum cost. To check that, what we do is this 60x plus 80y, this was Z, right? This Z less than 160, we will draw this half plane. I repeat, Z less than 160, we will draw this region or this half plane and check whether it overlaps or coincides with this region. If there is no overlapping, 160 will be the minimum value, otherwise the function does not have a minimum value. Now when I simplify it, first I will rewrite it as a 6x plus 8y is less than 8, sorry, less than 16, or I get a 3x plus 4y is less than 8, correct? 3x plus 4y is less than 8. Now, x, if I consider the point, it will be 8 by 3. 8 by 3, I have the point here, correct? And the other one is y by 2. 2 is the point here. This is the line, that is 3x plus 4y less than 8 is, I think we already have drawn this line. We will have to find out, this is the line actually, 3x plus 4y greater than 8 is the region what we got, but here the region what we have to find out here is actually 3x plus 4y less than 8. For this line, if I consider less than 8, substitute the origin coordinates, it's right. So, the half plane here is going to be below this line, which absolutely does not in any way has any overlapping or anything common with the feasible region. So, you see that 160 will be the minimum cost. The question was to find out what is the minimum cost of the food. Question was determine the minimum cost of the mixture. So, you will conclude it as minimum cost is rupees 160. Minimum cost will be equal to rupees 160. This cross checking for for especially unbounded region, when you have to find out the minimum Z value, compulsorily has to be done. Do it, check that there is no overlapping and conclude that the minimum cost is equal to 160 rupees in this case.